Good morning, children. We are going to practice IGCSE paper code 0625/21, May June 2018. Paper 2, multiple choice extend. Let's move to the question number 1. Here we have question number 1. A length of cotton is measured between 2 points on a ruler. When the length of cotton is wound closely around a pen, it goes around 6 times. What is the distance once around the pen? So here, children, first what you can do, you have to measure the length of this cotton. Here I can see it is 2.5 centimeter, and the other side this is 15.5 centimeter. So what is this length of cotton? 15.5 minus 2.5, that is equal to 13.0 centimeter. Now this cotton whose length is 13 centimeter is wound closely around a pen, as in this diagram, and about 6 times. So what is the distance once around the pen you have to calculate? So that distance once the pen, you can calculate the total length of the cotton thread divided by the number of turns. So how many turns are there? 6. So 13 divided by 6, you can find that about 2.2 centimeter. You can use calculator and you can check your answer that it is after dividing. Question number 2. We have in question number 2, when does an object falling vertically through the air reach terminal velocity? Object reaches to the terminal velocity when acceleration of the object becomes negative. No, there are certain conditions when the object moves to the terminal velocity. If object is falling downward, when the total weight or the total forces in the downward direction becomes equal to the total upward forces, that the air resistance, air frictions, when it becomes equal, then object reaches to the terminal velocity. So we need to find out such answer here. When the acceleration of the object is equal to the no, when the air resistance equal to the weight of the object, okay, and when the air resistance is greater than no, when it is greater than, that still it is wrong. Terminal velocity is achieved when all the upward forces becomes equal to the all the downward forces, that is the weight of the falling object. So question number 2, the right answer is C. Next question. Question number 3. Here we have in question number 3, a car is moving along a straight level road with a constant acceleration. Acceleration is constant, my dear children. Which graph shows the motion of the car? Constant acceleration in a speed time graph. Okay. Acceleration we can calculate from the speed time graph. So you have to go direct to the speed time graph. So in C and D, and in if you see option C, the speed is constant. If the speed is constant, and if the speed is constant, then acceleration equal to 0. So this answer is also wrong. But we have a straight line passing through the origin. Then if you find the gradient of this line, it will give a constant slope, and that is a constant acceleration. Given the gradient, you can find the acceleration from the speed time graph. The right answer is here, D. Next question. Question number 5. Diagram 1 shows a beam balance. A beaker with a wire loop balances the standard masses. The beaker is then removed and hung from a spring. The spring extends by 5 centimeters, as in diagram number 2. So here we have the two diagrams shown in this question. Diagram 1, where we have a certain mass, standard masses are there, a beaker with a wire loop. So this question is about the masses. We are measuring mass. On the diagram 2, that this beaker is now placed here on the spring, and due to that some extensions producing the wire, and how much? 5 centimeter long. Now in the next part here, they said the experiment is repeated with the same apparatus on the moon, where the acceleration of free fall is less than the acceleration on the earth. Which statement describe what happens on the moon? Now on the moon, children, the beam balance is balanced. The beam balance is balanced, yes. Because on the beam balance we have placed masses, and on the moon, or even we move to any planet, the mass remains unchanged. So in option C and D, they said the right balance beam is higher, right balance beam is higher. So this C and D are wrong answers. Okay, now we have to find the exact right answer from A and B. Now they said in option A the spring extends by 5 centimeter, and in option B they said the spring extends by less than 5 centimeter. In on the moon, as the gravity is less than weightlessness we feel, so the instead of the extension will not happen, but the spring extends by less than 5 centimeter as compared to the on the surface of the earth. So the right answer will be there, B. Next question. Question number 5. An object always has mass but doesn't always have weight. Mass is there, doesn't always have weight. What must be present and acting on the mass for it have to weight? For weight, weight is a force, and that is given by mass into gravity. So that out of these four options, the gravitational field should be there, and the A is the right answer. A set of scales, displacement, water, friction due to air is not the right option. Question number 6. A force acting on a moving ball causes its motion to change. Force, a force acting on a ball causes its motion to change. This force stay constant. What makes the force produce a greater change in the motion of the ball? Force is constant. How? What changes should we do that greater change in motion of the ball is there? Greater change in motion means that the greater is the acceleration, accelerated motion. So if we go with the option decreasing the total mass of the ball, increasing the temperature is not changing the acceleration, using a ball with a hollow center of mass, using a different material for the ball so that it is lower density, but the mass is same. Recall from the Newton's second law, children, A is equal to F divided by M. F is constant, so here are A inverse proportion with the mass. If I increase or decrease the mass, then I can make the acceleration. So if I decrease, as per the option, if I decrease the mass, so accelerated motion will be there. Still, I can produce the acceleration. So we will go with the option number A. Question number 6, answer A. Next question, children. A balloon and a mass are attached to a rod that is pivoted at point P. The balloon is filled with helium, a gas less dense than air, so that it applies an upward force on the rod. The rod is horizontally and stationary. Which action causes the rod to rotate clockwise? Look at the diagram. As present, uh, this diagram, the balloon means this is an upward force, and the mass means it is a certainly a downward force. Due to this, upward force, the balloon will make that this rod rotate about the pivot in the clockwise direction, and the mass in the anti-clockwise direction. But the balloon is filled with helium, a gas less dense than the air, so that it applies an upward force on the rod. The rod is horizontally and stationary. Now it is a stationary. Which action causes the rod to rotate in the clockwise? Finally, we want to rotate this system in the clockwise direction. What should I do? If I go with the option A, move both the balloon and the mass 10 centimeter to the left. 10 centimeter to the left. 10 centimeter to the left means If I place the balloon here at 40 and the mass is at point this, then what happens? If I placed it here, both are moved to the 10 centimeter will not make it to rotate in either direction because the both are moved into the same direction. The still the system will remain in equilibrium. But if I go with the option B, move both the balloon and the mass 10 centimeter to the right. Okay, let me take to the right. Now the balloon is placed here. That is the upward force, and upward force will make a torque or a moment about the pivot point that it will try to rotate in the clockwise direction. And what about the mass? Mass should be placed on the 10 centimeter to the right. 10 centimeter here, which is not here but here. And so in this situation, what happens? The torque about pivot point is smaller as compared to the clockwise moment. So this makes that the overall, the resultant clockwise movement will be higher compared with the anti-clockwise movement. So for the question number 7, we can go with the option B. Even if we go with option C, move both the balloon and mass to the 25 centimeter mark. If I keep them at 25 centimeter, what happens here? What happens, children? Still, the anti-clockwise movement will be higher. You can see that the distance, the total is 45 centimeter. This is placed at 25 centimeter. So still, the beam will tilt or align or move in the anti-clockwise direction. So rest of the answers are wrong. Correct answer is B. You can also find some other method to do this question, but here the answer should be 7th B. A car is moving in a straight line on a level road. Its engine provides a forward force on the car. A second force of equal size acts on the car due to resistive forces. Which statement describes what happened? What happened, children? There is a forward force of the car. A second force of equal size acts on the car due to resistive force. What happens? One force in the forward direction, another force of the same magnitude in the backward direction. The car changes direction, not possible. The forces are same. Car move at a constant speed, yes, it is possible. Car slow down, no. The car speeds up, no. The car, the same forces are acting on the car will move with a constant speed. Question number 8, answer is B. Next question, number 9. Which expression gives the momentum of an object? It's a simple question. Momentum is given by, write this P for the momentum, which is the mass multiplied by velocity. So where I can find mass and velocity? Option number C. Question number 10. As energy is transferred into different forms, it eventually becomes dissipated. Eventually dissipated. Okay. What does this mean? Energy is transferred into another form. All the energy disappears? No. All the energy disappears. Energy transferred from one form to another form. The energy finally changes into every possible form of energy. Not every possible form. It depends upon uh, kinetic energy is converting into the potential energy converting into the kinetic energy. Not that it will convert into some all the forms of energy that is available. The energy spreads out among the objects. Yes, it will spread out among the object and their surroundings. So energy is converting from one form to another form in the object and then to the surroundings. Surroundings like if a collisions take place, then the kinetic energy converted into the potential energy, and that form may be some part of the energy may be in terms of heat and the sound. So some part of the energy is converted or transferred into the object, and some part of that energy is dissipated or transferred or converted into in the form of heat energy or the sound energy. So the question number 10, children, the right answer is C. The energy spreads out among the object and their surrounding. Question number 11. A ball of mass 1.2 kilogram is dropped from a height of 30 meter. As it falls, 25% of initial gravitational potential energy is transferred to thermal energy. What is the kinetic energy of the ball just before it hits the ground? I'll tell you what's happening. What's happening here? Object is a certain height. So I know at a certain height there is a gravitational potential. How much is that? We have an equation mgh. I can calculate that value from this equation. 30 uh, 1.2 is the mass. G I can take 10 and height is given 30. So if I multiply and if I remove this decimal here, this 0 cancel out by this 12, this is 360 of Joule. So we have this amount of potential, gravitational potential energy. But in the question they said 25% of it is is transferred to the thermal energy, and the remaining 75% appeared in the form of a kinetic energy. So you can find out the 25% how much energy has been lost. I can find out the lost in energy by finding its 5 5s of 5 to the, and finally this is 18 5s are 90. So what is this 90 joule? 90 joule is the energy lost. Some students by saying the 90, that 90 is answer. No, that is wrong. This is the lost in energy. We have to find how much kinetic energy is there. What is the kinetic energy? So potential energy was 360 joule. I have calculated here. 90 joule has been lost in terms of heat. What is the remaining of this? 360 minus 90 is 270. Option C is the right answer, children. Have a look on this solution. Now move to the question number 12. In question number 12, a girl hangs by her hands from a bar in the gymnasium. She pulls herself up until her chin is level with bar. The mass of the girl is 48 kilogram. She pulls herself up through a distance of 0.25 meter. She does this in 2 seconds. What is the useful power she uses to pull herself up? Useful power. How to calculate, children? The useful power. The useful power is given by P is equal to that. There is an equation, useful work done per unit time. So in raising up that, the work done will be stored in the gravitational potential energy. So we are using the formula for gravitational potential energy, mgh. How much work is done in raising to a certain height, that is mgh. To calculate the power, we need to divide by time. Mass of the curl is 48. G we will take 10. It is given in the question paper in the beginning of the instructions. Height is, how much is the height? To a distance of 0.25, I will take 25 by removing the decimal points, and then time is given 2 seconds here. You need to use your calculator, children, and I'm doing this without calculator. 5 5 are 5 2 are, and then 2 2 are 24 here, and then 12, and finally 12 multiplied by 5 is 60. So 60 watt. Power has a unit of 60. Sorry, power has a unit of watt, so that the answer will be 60 watt. Next question. Four identical beakers are filled with equal volumes of liquid P or Q as shown. Liquid P is more dense than liquid Q. At which point is the pressure least? We're talking about the least pressure. So you can find the least pressure, the less height, because we have one equation for the pressure. Pressure in a water under depth is given by H, density, and G. So I need to find the least pressure. So least pressure will be either at point B or at point D. So, but in the question they have given the these two cylinders containing liquid of different density. They said liquid P is more dense. More dense the liquid, more pressure it will exert. So it means compare with the pressure at B and pressure at D. So pressure at point B will be higher as compared to pressure at point D, because the density of liquid in Q cylinder at D point will be less. So we will go with the right answer with option D. Next question. The next question is, an oil tank has a base area 2.5 meters square and is filled with oil to a depth of 1.2 meter. The density of the oil is 800 kilogram per meter cube. What is the force? We need to calculate the force. There is one equation that gives the relation between pressure and force. And what is that equation? The pressure is given by force divided by. I need to calculate this force. So if I shift the term, so sorry, the pressure will be force is equal to pressure multiplied by area. Direct pressure is not given. Sometimes the value of direct pressure is given, so you can put that value here. But in this question, I can use uh, pressure in an oil tank with the equation, as I told you earlier, H density G into area. Now you have to substitute all the values. What is height? How much is the height? Depth, that is 1.2. Density is given 800. Into G, I will take 10. What is the area of the base? That is given 2.5. Multiply all these factors and you will get that 24,000 Newton is the answer. So this force having a unit Newton. Next question. Question number 15. When molecules of a gas rebound from a wall of a container, the wall experiences a pressure. What is the cause of this pressure? The cause of this pressure is not energy change of the molecules, not the power, not the speed of the molecules, but this happens as the change in momentum of the molecules. So we will go with here option number 15B. Question number 16. A student wishes to calibrate a mercury in glass thermometer with a scale. Which value should she uses for the lower fixed point and the upper fixed point? So lower fixed point and upper fixed points are always in a thermometer. There are 2 points: fixed point, lower fixed point, and upper fixed point. So lower fixed point is maintained at a melting point of ice, which is there in option A and B. So C is wrong, D is wrong. And upper fixed point is maintained the boiling point of a liquid. So liquid boiling point of water or of mercury. So the right answer is here B. Question number 17. Which statement about boiling and about evaporations are correct? Evaporation, children, take place at any temperature, but it take place at the surfaces. Boiling process not take at any temperature, but at the 100 degrees Celsius of temperature in case of a liquid, and it can take anywhere in a liquid. So that option you need to find out. If you are aware about the boiling process and the evaporation, then you can find easily the answer. So take place only at the surface, no throughout the liquid it can take, so either option C or D. Take place only at the surface, take place throughout the liquid, evaporation take place at the surface. So right answer is C. Question number 18. On a cold day, a metal front door knob X and a similar plastic knob Y are at the same temperature. Okay. Why does X feel cooler too much than Y? You read again. On a cold day, a metal front door knob X and a plastic knob is Y are at the same temperature. In a room, suppose I have two handles, one handle made of plastic, other handle made of metal. If I touch metal, so I feel more cold or colder than compared with the if I touch the plastic handle. So why this happens? Why does X feel cooler to the than Y? The right answer. Because X is a better thermal conductor, metal is a better conductor as compared with the plastic, which is a non-insulator, means which is an insulator, sorry, and that doesn't conduct or poor conductor of heat. X is not a better insulator, X is better radiator, no, then X converts thermal energy better than Y, no, convection. So X is a better thermal conductor than Y. Question number 19, children. Question number 19, what we have given, light travels at a speed. This is the speed of light, velocity. Wavelength is given, what is the frequency? Okay, so we have one equation that you need to remember, V equal to F divided by lambda. So I need to calculate the frequency. So frequency will be, if I shift the term, so this will be velocity by lambda. How much is the velocity? 2 times 10 to the power 8. What is the wavelength? That is 4 times 10 to the power minus 7. If you do the calculation here, then it will be 1 by 2 times 10 to the power 8 plus 7, and 1 by 2, that is 0.5, 10 to the power 15 plus 15, frequency unit is hertz. So I couldn't see this is minus 15, that is wrong, this is wrong, this is wrong. So something this answer will be, if I can write my final answer is by changing the decimal point 5.0 times 10 to the power 15 hertz. So that is the answer. One more question, children. Question number 20, which arrows on the graph shows the amplitude of the wave? Amplitude, the maximum displacement of the particles when a wave is propagating. Maximum displacement of a wave from the origin point, from the center line. So this is the amplitude. This is, some students they consider this is called the amplitude. No, this is not the amplitude, children. We have to consider the amplitude of one crust, or even the maximum displacement of the particles towards the trough side. So B is the, let me clear this, and B is the right answer. That is the amplitude. C is also not the amplitude. That is the half wavelength. D is also not. This is the wavelength actually. This question is about find the wavelength of the wave. Then wavelength of the wave is by the letter D. So they asked about the amplitude. Amplitude is B here. Naturally, I want to stop my lesson here, and the remaining, we have discussed 1 to 20 questions. Remaining questions 11 to 21 to 40 we will discuss in our next recording. Thank you, children. Have a blessed day.